Aggregate visualizations, stacked bars and line charts, are a common technique for helping users understand datasets as parts of a whole. Several typical examples include breakdowns of sales by season and type, barrels of oil per year, and patients broken down by disease and age. Several systems are using animated transitions between different visualizations to help users understand the data better. For instance, when filtering out names in the baby name Voyager, we can watch as we type S, T, E, and see how the visualization smoothly interpolates between states to allow the user to track what is going on. Microsoft's Pivot Visualizer represents every item as a single image, allowing you to zoom in and out of the collection. They also allow you to represent aggregates along different groupings. The individual elements are moved to their new positions using a randomly staggered start time. The Dynaviz project allowed for general animations between visualizations, but does not specifically handle aggregate data visualizations. We are interested in constant area transitions, which maintain constant size as items move around. The SandCastle system allows us to explore the design space for transitions in aggregate visualizations. It supports three basic operations: grouping, filtering, transposing, or changing the x-axis. Let's look more closely at these basic primitive operations. Grouping is straightforward. Fading in the subgroups over the larger groups, we have control over the duration of the transition. Filtering, however, is more complicated. We can filter based on a number of different criteria. First, we'll look at filtering out a subgroup. The filtered subgroup is moved off screen in stage 1, and in stage 2 the other groups are moved to fill the gap. And finally, the overall chart is scaled to fit better onto the screen. To go back, we reverse the order of the transitions. Next, we can filter out a subgroup that is not currently shown. Here, the corresponding portions of each subgroup are moved off screen, and then the groups are moved to fill in the gaps. Finally, we can filter out a group when an entire column is removed, and the columns are then moved closer to make up the horizontal gap. In these transitions, we can control the rates at all stages, and we can also stagger how the items are removed or how the columns are updated. Transpositions are even more complicated. We can perform the transition in place, but a linear path makes items occlude each other, which can make the transition confusing. We can change the path to a rotational transition, which is much less confusing, but ordering information is changed between the charts. Instead of in place, we can make transpositions between graphs that are placed side by side to each other. Timing is again controllable at every stage. Also, there are a variety of options that we can use for staggering the start and ending items. We can make the graph move in a row-centric or column-centric fashion. We can fill the resultant graph from top to bottom, or bottom to top, left to right, or right to left, or using a random staggering. Each can convey different information. Finally, in all the transitions we've discussed so far, we've been using a constant size rectangle to represent the data. We can break the rectangle up into pixels and move the pixels around instead of the rectangles, achieving a fluid transition that helps engage the viewer, as well as reinforce the notion of aggregate data.